Lesson 4, Reading 1. How can two objects of the same size have different masses? Getting ready. If you were sitting at a table and in front of you were a loaf of bread and a cement block that were the same size, which one would be heavier? You probably do not need to do scientific tests to answer this question. You could easily pick up the loaf of bread, but the cement block would be harder to pick up. Even if a cement block and a loaf of bread have the same volume, they have different masses. They take up the same amount of space, volume, but the amount of stuff or matter in them is different, mass. Thinking about the bread and cement block may help you learn about another property of substances called density. Liquids and gases also have density. This reading will focus only on solids, however, like the chalk you investigated in class. How can I use mass and volume to get a property called density? Imagine for a moment that one of these two cubes is cement. If you doubled the volume of the cement, if you had twice as much, what would you expect to happen to the mass of the cement? You might suppose that the mass would double because you have twice as much cement as you had before. Embedded text-dependent question. What if you broke off a piece of cement or bread so that it was only half the volume of the original piece? What would happen to the mass? Even though cement and bread are not substances, they can help you to understand these concepts. Whatever you do to volume affects mass the same way. Whatever you do to mass affects volume the same way. If you have half as much of a material, you would expect the volume of the material to also be half as much. If you have twice as much of the material, you would expect its volume to be twice as much. Substances, which you know are always the same throughout, will follow this rule. The relationship between mass and volume will stay the same for any substance, no matter how much of that substance you can sample and measure in the classroom. Embedded text-dependent question. Why is this principle about the relationship between mass and volume always true of substances, but not always true of mixtures? The relationship between mass and volume is what scientists call density. Density is the mass in a set volume of a substance. You may have heard the word dense before. When something is dense, it has a lot of mass for a little volume. You could say that cement is denser than bread. The amount of mass for a set volume of cement is more than the amount of mass for that same volume of bread. This mass-volume relationship is important because every substance has a specific mass-to-volume relationship. Every substance has a specific density. How can you determine density from the mass-volume relationship? In class, you saw that pieces of chalk had the same density, even though they were different sizes. First, you measured the mass and volume of each piece of chalk. Then, for each piece, you divided its mass by its volume. The numbers you calculated for each piece of chalk should have been very similar to each other, around 2.5 grams per centimeters cubed. The G stands for grams, the mass of the chalk. The centimeters cubed stands for cubic centimeters, the volume of the chalk. The number with the G/centimeters cubed is the density of the chalk. You read the measurement, grams per cubic centimeter. It tells you about the mass to volume relationship. The measurement of volume that scientists use when talking about density is 1 cubic centimeter. The following cube is approximately 1 cubic centimeter. 1 cubic centimeter is a measurement for the volume of substances. The cube takes up space that is 1 centimeter high, 1 centimeter wide, and 1 centimeter deep. When you calculate the density of chalk, it is like you are saying that for every 1 cubic centimeter of chalk, you would have 2.4 grams of chalk. Two ways to measure volume. In class, you learned that the unit 1 cubic centimeter and 1 milliliter are two ways of stating the same measurement. You can see this by measuring an amount of water in a graduated cylinder. If you drop a 1 cubic centimeter block into the cylinder, the amount of water it displaces will equal 1 milliliter. Look at the picture of the graduated cylinder. If the water level starts at 30 milliliters and you drop the 1 cubic centimeter block into the water level will rise to 31 milliliters. That means that the water has been displaced 1 milliliter. 31 milliliter minus 30 milliliters equals 1 milliliter. In other words, a 1 cubic centimeter block displaces water by 1 milliliter. These two units, 1 cubic centimeter and 1 milliliter, can both be used to represent the same measurement. If you have the opportunity, you can do this in class so that you can see they are the same. When you refer to density, you can use either measurement, just as scientists can, 31 milliliter, water measurement after adding 1 cubic centimeter cube, minus 30 milliliters, water measurement to begin. 1 milliliter difference equals amount of water displaced. Therefore, 1 cubic centimeter equals 1 milliliter. This reading contains sections about calculating density and further developing the concept of ratio. These sections are provided for teachers who wish to go into some depth about density. Density tells you about a substance. If you know the volume of a substance, the density can help you predict how much of a substance you have without measuring its mass. If you know its mass and its density, you know how much space a substance will occupy. The density of aluminum is always 2.7 grams per milliliter, no matter how big or small the piece is. Use aluminum's density to fill in the missing boxes in the following table. To fill in the boxes, ask yourself, if I have 2.7 grams of aluminum for every cubic centimeter, then how much aluminum would be in 2 cubic centimeters? Based on aluminum's density, how much volume, how many cubic centimeters, would 0.85 grams of aluminum have? Remember that whatever you do to a set volume of a substance affects the mass in the same way. How do scientists always get 1 cubic centimeter when figuring a substance's density? It is often difficult to determine the density of something because most objects and most samples of substances are not exactly 1 cubic centimeter in size. Scientists use math to determine density no matter what mass or volume of a substance they have. As long as you know the mass and volume of something, you can determine the density by determining the mass to volume ratio. You can do this by dividing the mass by the volume. Mass divided by volume equals density. Using the formula, a person can determine the density of the bread and cement block. For example, even though they have a whole loaf of bread and a whole cement block in front of them. The formula allows a person to calculate without having a 1 cubic centimeter sample of each substance. The formula allows scientists, or you, to calculate the density of any substance no matter what mass or volume of that substance they are measuring. Density is a property of substances because every substance has a characteristic density, and that density does not change. A substance always has the same density. A small sample of the substance has less mass and takes up less space, but it has the same density as a different sample of the same substance. If the two cubes were both made of iron, their density would be the same. It does not matter if the larger sample has more mass or takes up more space. The mass and volume change, but the density of a substance is always the same. Embedded text-dependent question. If you tripled the volume of your sample of chalk, what would happen to the mass? Embedded text-dependent question. If you doubled the volume of your sample of chalk, what would happen to the density? Try this at home. Here is another way to observe the principle of density that may give you some surprises. Ask an adult if you can try this experiment at home. You will need a glass container that you can see through. A drinking glass, measuring cup, or empty jar will work. One at a time, you should slowly pour equal amounts of the following three liquids into the container: vegetable oil or baby oil, corn syrup or pancake syrup, water. Keep a chart of your observations. You may even want to draw what you see. What do you observe? What does this tell you about the density of the liquids and the objects you put into them? Now, predict what will happen when you add some objects to your container. Try adding a paperclip or a safety pin, a toothpick or a cork, a grape or a raisin, a birthday candle, and a rubber pencil eraser. If an adult can show you how to separate an egg yolk from an egg white, predict what will happen when you drop an egg yolk into the container. Then do it. What does this investigation tell you about the densities of the materials you used? Maybe you can report what you learned back to your classmates.